Hello friends, now we will start geometry and with similarity. Very interesting topic. Do you know what is the meaning of similar? We say that son is looking like father. That means son is similar to father. This small ball is similar to big ball. Or we say this small triangle is similar to big triangle. What is the actual meaning of the similarity? The actual geometrical, mathematical meaning of the similarity of two triangles is, see here. If two triangles, suppose triangle ABC is similar to triangle DEF, we just write triangle ABC is similar. This is the symbol for similar. Is triangle DEF. If that is similar, what is the meaning of that? Firstly we will get, then we will just see how to prove the triangles to be similar. Then we will see what result we will get if we prove the two triangles to be similar, what extra results we can get. Now see, if two triangles are similar, the most important thing we know by the meaning of the similarity that their parts will be in proportion. What are the parts? The parts are the three sides and the three angles. That's all. Now, we can just say AB by DE will be equal to AC by DF will be equal to BC by EF. So, and all the corresponding angles will be equal. A will be equal to D, B will be equal to E, and C will be equal to, that's all. If we prove the triangles to be similar, that's all. The angles will be equal and the sides will be proportional. Very simple. Now see where we can make use of that concept and how can we make the concept useful in solving the problem. See, how to write firstly that triangle ABC is similar to DF. Just I give you a simple technique. Go with the nomenclature. A is corresponding to D, so angle A will be equal to angle D. B is corresponding to E, second letter. B will be equal to angle E. C will be equal to angle F, that way. How to take the sides? If we are taking AB, first two letters, I have to take DE. If I am taking AC, I have to take DF. Taking BC, we have to take EF. Suppose, you might be thinking this is quite simple, what extra technique you are giving? The thing is that if somebody is saying you triangle ABC is similar to triangle EFD. So, can you tell me which angles are equal and which sides are proportional? Angle A will be equal to angle E then. So for that thing, it will be angle A is equal to angle E, angle B is equal to angle F, and angle C is equal to angle D. See, like this. So be careful how to give the nomenclature and how to make use of the nomenclature. That is very conducive technique that will give you results and 100% results. See, now the sides in ratio will be AB will be proportional to EF. How I am taking? Two letters here, two letters here. AC is proportional to ED and BC is proportional to FD. Okay. So, if we prove the triangles to be similar, we can just give the name to the triangles in a systematic way and we can just harvest the things. We can get the result easily by taking the ratio of the sides in accordance with the nomenclature. Now the thing arises, how can we prove the triangles to be similar? Very important theorem I am giving you. The result you got after similarity, sides will be proportional and angles will be equal, corresponding angles. So how to prove the two triangles to be similar? is first theorem is AA theorem, that is known as very common. Sometimes we go for AAA theorem, but AA is doing everything. That is angle-angle theorem. The meaning of this is that if two angles of two triangles are equal, they are definitely similar. You know, if two angles are equal, third must be equal. And if three angles are equal, that is automatically a similar triangle. So to prove the two triangles to be similar, we use this theorem. See, suppose a triangle is like this, angle A, B, C, and it is a right angle triangle, and this is P, Q, R. This is right angle triangle, and it is given that angle B is equal to angle P. So, how we will write? We will just write in the fashion I am telling you, in triangle ABC and triangle PQR. Anyway, you can just write the name. Once we are writing the similarity symbol, we will take care of the nomenclature. So, angle A is equal to angle Q. Angle A is equal to angle Q. Why? 90 degree. Just write the reason. It is given in the question. And angle B is equal to angle P. Why? This is given. Just write in this fashion. Don't write angle A, just write in three-letter form. Angle A will be written as angle BAC. Just follow the technique. I am just doing this to just see how the theorem is applicable. Okay. So, two angles are equal. That means these two triangles are similar. By which theorem? By AA theorem, angle-angle theorem, similar. Now we can say that triangle ABC is similar to triangle. Now be careful of nomenclature, because then we have to prove the sides to be in proportion. So, if I am just writing ABC, I will be careful in naming PQR. We know that angle A was equal to angle Q. So, first letter is A. So, first letter will be Q. Very simple. Now, angle B was equal to angle P. B is at the second place. So, P will be at the second place, and third place it is whatever left over is there. So, this triangle is now similar to that triangle that we have proved. And we have given the nomenclature accordingly. So, we can take the ratio of the sides in nice manner. See here, we can just write AB by, what is that? If I am writing AB, it will be QP. If I am writing BC, what is that? This is PR. If I am writing AC, what is that? QR. That is the ratio. Just student ask, what's the use of taking the ratios in proportion? Sometimes this is given, suppose AB is given 5, QP is given 3, BC is given 8, and somebody is telling you to find PR, or AC is given 7, you have to find QR, like that. Okay, so you can make use of the theorem, the result of the similarity, to get the unknown side easily. You can get PR from here. How? You can just write PR into 5. 5 into PR is equal to 8 into 3, that is 24. So PR is equal to 24 by 5. You can get, same way you can get QR. So you can get the unknown sides very easily. Now see, I will take a special case where it is a right angle triangle, and from that 90 degree angle point we drop a perpendicular on the opposite vertex. This is suppose ABC, this is point D, and we have to prove triangle ABC. To prove triangle ABC similar to triangle BDC, like that. Okay, we have to prove. So see, we have to prove the two triangles. We will see that where the two angles are equal. Now we will see ABC. We can just draw ABC as a full triangle. ABC form drawing like this. This is ABC. And BDF we are drawing like this. BDC. This is BDC. Now we have to see which angle is equal to which angle. Very common thing is that angle B, which is 90 degree, is equal to angle D. Angle D means angle BDC. Angle BDC. Why? Because 90 degree. And one extra thing you are seeing. This was equal to this. And extra thing is that C is common in both the triangle. So we can just write angle C. That means angle ACB. Better I will write in that fashion, ACB. That means C of ABC. And here we will write BCD. C of triangle BCD. Why that are equal? Because both the angles are common. Common means same, existing in both the triangles. So now by a theorem, we can say that triangle ABC is similar to, just write the name of one triangle. Be careful writing the name of the second triangle, because that is to be given in accordance with the first triangle. So ABC is there. Now C, which was equal to which? We B was equal to D. So B is at the middle center. So we will write D here. C is common. C is at last. So C at last. And what we left with? B. So BDC. So now we can take the ratio of the sides. How? Just we will write AB. Then we have to write BD. We write BC. We have to write DC. We write AC. Then we have to write BC. So we can get very good result, that is BC square is equal to AC into DC from here. Same way, if somebody is telling you to prove this triangle to similar to full triangle, you can prove. Now you have proved this triangle is similar to full triangle, and you can also prove this triangle ABD is similar to full triangle. So you can prove the two small triangles to similar to each other also. That you can use, because both are similar to the big triangle, so they are similar among themselves as well. Hope you are understanding the very basic concept of the similarity of triangles. Thank you.